This looks like a good enough place to start. Welcome to episode 2 of designing a simplistic dungeon-style game using just JavaScript and some basic HTML and CSS. In the previous episode, we walked over quickly making our skeleton HTML page. It comes with the HTML tag, a body and a head tag inserted into it. Inside the body tag, we have the canvas drawn in with a game canvas ID, and when the body has onloaded, it will call a function called onload, and whenever it gets resized, it will call a function to resize the canvas. Inside here, we've linked a reference to a CSS sheet and a reference to a JavaScript sheet. In the CSS, we just simply set the color to FFF. I'm going to change that to 000, which is going to basically make it black. Make it black. Have I got the right thing open? No matter. Oh, it's background color I want. There we go. So we have a CSS sheet that does the styling for us, and then wrong file. Over here we created the let's fold these up a sec so we can more easily look at them from about above. We've got two constants defining the width and the height of our game window. We've created two variables, or lets as this is called, a canvas and a context. In the onload function, we define the canvas and the context by linking the canvas to the canvas we put into the HTML, and the context is where we put all the commands to draw things into the canvas. We set the canvas width and height to the game width and game height, and we call a function to draw a bunch of squares. Then to the resize function. The resize function simply scales everything up to the right proportions, so even when we make this window bigger or smaller, it will still look the same. And for good measure, this will be more relative when we start adding sprites into it. We make sure that all image smoothing enabled are disabled, and we put in every type of browser that there is out there. There might be some new ones, because this is a few years old, this stuff that I was working with. And then again, we've set it to draw these squares. Now we've covered just about everything that we did in the previous video that I showed. I'm going to move into what I want to cover in this video. The three things will be creating classes. After we've created the classes, we want to set up an animation loop. And after demonstrating how the animation loops works, we're going to add in keyboard controls with event listeners. Now I've got that part out of the way. I'm going to start up talking about about classes. Conceptually, classes are comparable to a class in programming would be like cars. Cars would be like a class. When you have a car, you expect there to be things that come with cars, like a steering wheel, the car seats, the seat belts, the car doors and windows, and the engine, and all those sort of things that come with it. That no matter which kind of car you're talking about, whether it's Volkswagen or Tesla or so on. Similar with a bicycle. If you talk about a bicycle as a class, you would talk about bicycle coming with certain things that would be expected of a bicycle. We're going to do a similar thing where we create a class, and this class is going to be not a square but a rectangle, simply because squares are, the same width and same height and everything, but rectangles can have different properties to them. Not all rectangles are squares. Yeah. And when we create a class, it always comes with a constructor. whether or not you write a constructor, this constructor will exist anyway. And inside the constructor for a rectangle, we would describe the things about a rectangle that you would expect when it comes to games programming. The first two that we would give it will be the x property. Like over here, we have the distance to the left and the distance from the top. And the next we want to give is the width and the height. How wide is it and how long is it? Quite clear. Next up, we want to give it a fill style. What colour is it going to be? This one is grey. What kind of a stroke style it's going to have? This one has red, while all the other ones have blue around them. And then a line width. I believe that was all the things that we defined in our previous video about them. Line width, fill style, stroke style, yeah, that's all of them. And inside the constructor function, we want to make sure that this rectangle takes on all of these properties. One way we can do this is using the keyword this. When we call the keyword this, the object that's being created here in the scope, as they call it. Inside the scope of this constructor is this object, this rectangle. That is what the word this is referring to. This.x can equal x, this.y equals y, and etc, etc. But I'm not going to do it quite like that. I'm instead going to use a JavaScript native command, which is object.assign. Inside to this thing, we're going to assign a list, all this list of properties here. I'm going to copy that now. Copy it. With Control C. You can always right click and say, copy. And then the first argument for object.assign, similar to how these are all arguments inside these parameters here. I don't know what they're called, commas, brackets. I'll set for brackets. These are arguments within these brackets. Within these brackets, we are giving it two arguments, as they seem to call them. I don't know why they're called arguments, they just are. And as I said, we will copy all of this, not cut. We paste all of them into here. Now inside here we have object assign is, and it's assigning to this rectangle all of these properties here. That's one way I like to do things. Now, when you create a square, like let square equals new rectangle, you would expect to be asked to fill in all of these arguments here. So you might think, oh, I have to type in 5 for x, 10 for y, a width of 32, and a height of 60, fill style, black, stroke style, yeah. And what if you're creating lots of these and you get sick and tired of writing all these in? Well, then you can just put that in, if they're in here. And what this will do then, just keep that there a sec, you can give it default properties. So if you do not provide all of these this whole, like if you don't fill that whole form in, it will have some defaults. We are going to write some defaults for us. So by default, I'm going to set my x property and y property to 0s and 0. The width property and height property are going to be set to 32 pixels. The fill style can be set to black. I might give it something else. How about 888? Basically a shade of grey, if you will. The stroke style, we'll give it FFF, and a line width of 2. This way, when I create a square or rectangle, I don't have to fill in this entire form now. It will be done for me. Now, outside of the constructor and into a new function, we're going to create a function inside the rectangle, so the rectangle will know how to draw itself when it is given this context. Similar to the context that it will be the same context that we made up here, but I'm going to reference it here every time I call this draw command inside this square, just to make sure that if we later change the name of context, or if we were using modules and importing, etc., then we will always make sure that we pass a reference of that context into this draw command. And inside the draw command, we can take basically all this stuff that we set over here. That margin I'll take out. Everything from stroke, setting the context stroke style to context fill, can be copied into here. Set the margin. I'm going to remove this margin now. And instead of those quotation marks of blue, we're going to type in this dot stroke style. If anyone's not keeping up with me, make sure that you are putting in the capital S here. That's what I've been typing in so far. The line width will be set to this dot line width, again, capital W. Fill style is set to this dot fill style. And then when we create this rectangle, we're going to put in this dot X, this dot Y, this dot width, this dot height. I'm going to just make it all fit into one line there to look nice and neat. And that's basically the draw command done. Now, instead of having all this stuff over here, I'm going to remove that. I'm going to rename this square to main square, and I'm going to do main square dot draw and give it the reference of the context. So now it will be calling this over here. You're not going to notice too much different, are you? I've made an error already. As you can see here, we've already got the... Oh, cannot access... Yeah, I've tried to make this rectangle a bit too soon. I need to wait for the onload function to work. So I'm going to do over here, main square equals new rectangle. And then back down here, I'm going to just take that out. In fact, I'm going to move it up here so that all of the variables in this script are at the top. It's much neater that way. Now if I refresh, as you can see, all the default values that I gave it of 0, 0, 32, 32 and grey with a white lining around it are up here. Let's say I want to change it. So I'm going to give it X position 400, Y position 300, a width 50, height 75, a fill style of red, a stroke style of white, and a line width for 4. Just make it look fat. And then now there we go. I Control S, hit refresh, and we've got this square drawn where we want it. And that's just the basics covered for how to make a class sorted. Now this class knows how to draw itself and create itself, and we can create as many squares as we want, and all of those squares will have all the same properties and things as this one has. So if I wanted to, where I hit draw all these squares, I could just make a list here of list of squares, make that one of them, and then for wait, we did a nested loop, didn't we? So over here, we're going to do let new square equals new rectangle, and inside the rectangle's arguments we're going to give it an x pos of x times square width plus margin, y times square width plus margin, I wouldn't know how to pronounce your name there, but basically this stuff you can just follow along and type the same things I'm typing and you would still get the same results that I'm getting. You could use Notepad if you want and you would get these same results as well. Square width minus margin times 2, square height minus margin times 2. Now we don't need to have all this fake stuff over here. Oh yeah, this margin was 5. We're going to just insert that here. Margin equals 5. A lot of this is just copy pasted from before. So new rectangle, the x, the y, right, and then we wanted to give them black, blue, and line width of 2. Now in here we don't need all this stuff. Or let I equals 0. I is, this is a for loop by the way, and we're going to relate it. Wait a sec. List of squares dot push, as in, you know, this array. We're going to push this new square into the array, and it's going to do it just as many times as it did before to create this grid. And then down here in the draw square function, list of squares dot length. So I starts at 0, I is going to go on until it reaches the length of this list of squares, incrementing one at a time, and then it's going to do list of squares and the key, or the, you know, the 0 at first, the 0th one in the list, then the first one in the list, the second one in the list, and so on and so on. Dot draw, provide it the context, and this should be no different than before, unless I've made some mistake there in the height. How have I made a mistake in height? Square width, square height. Margin. Oh, this is saying square width, square height. Don't know how that one happened. We've got all the same results going on though. That's good. Now, with that out of the way, I've established how we use this rectangle class to create many rectangles, as many as we want, and make it look more efficient about it. The next thing we can now start to do is start replacing this whole draw square function with a animation loop. And the animation loop is going to be started in the onload function, and it's going to basically refresh and keep redrawing onto this canvas, and it's going to redraw all the list of objects that we had at a constant or a relatively constant frame rate. It will also allow us to put in commands that will allow us to move objects around on the screen and achieve motion through that. So the first thing I want to do is create a quick function called update. On the resize function, I'm going to remove draw square, and then on load I'm going to replace draw square with request animation frame, and put the word and put this function called update into it. Now over here I'm going to copy and paste the same command, request animation frame. What this now does for me is it's going to refresh this screen, unless I've done some kind of error. What have I done as an error? Oh, I haven't done anything as an error, I just haven't called it to draw things. So, draw square. That won't do anything different for now, but I'll get there. Main square dot x add equals 1. Just to start showing to you now, we now have animation. Ta-da! Looks fantastic. Until it goes off the screen. Keep it on screen for a little while. So now what we're seeing here is this request animation frame is being called as often as it can do it within as often as it can do it, which means that this could be happening depending on how often your browser refreshes, and there's goods and bads about that. If you're working with a 24 or 30 frame per second, this would be moving seemingly a lot slower than it is right now. If you're working with 60 frames per second, or something like, I don't know, my crazy friends who have 5,000 frames per second, this is going to move a lot faster across the screen. So in order to make sure that we keep this thing moving at a more constant rate, I'm going to create a variable called time inside the onload function. I'm going to say time is equal to performance.now, and then inside the update function, time is I'm going to create a new variable called delta, which is time minus performance.now. I might have this the wrong way around, so I'm going to use console.log delta, and it's going to output it over to the console over here when I start this up. Stop now, undefined. Have I made a mistake over here? Performance.now. Stop now. Hello internet, are you not working at the moment for me or something? Performance.now. Javascript. Let's see. It looks like I don't need a capital P for this. This built-in JavaScript function is without a P. So now I can see I've got all these 1,000 milliseconds, which is basically how long has this operation been running for. Now over here, time is equal to performance.now without the capital P. And what this is going to start telling me is about 14 or 16 milliseconds has passed by. I'm going to just swap these around so that I have a positive number. 15 or 16 milliseconds have passed since the last animation update has been performed. Now, actually, I'm going to replace that here. Time is equal to performance.now minus time. Console.log time. Is that going to still give me the same-ish results? Oh, just comment that out a sec. No, it's not going to work that way at all. I thought I had this in one line before, but oh well. Now, letting me know how many how many milliseconds has passed by is okay, but I'm going to go one step further and times it not by a tenth, not by a hundredth, but by 1,000th. You could just say the same thing, delta divided by 1,000 to hit the same number. So that but I know that computers can do multiplication faster than they can do division. Therefore, I'm going to multiply this by 1,000th, so that then I can transfer the number of milliseconds that has passed into a fraction. There we go. Now, if we wanted to move this square, let's say this square was going to move at a speed, let's say the speed is 800 divided by 5, that would look like 160. We want it to move 160 pixels per second. If I want it to move by 160 per second, 160 frames per second, then I would times that 160 by delta. Then over here in main square.x, we're going to add equal speed. Now it's going to move at a constant speed of 160 pixels per second, which is good because no matter what frames rates that your screen is refreshing at, it will still always move at the same speed. I'm just going to add in, if the main square.x goes over the game width, then main square.x equals 0. Actually, I'm going to make it equal to main square.width minus the main square.width. So that way, there it is, and there it's got, oh, it's come back again. And it's going to go off the screen, and it comes back again. Hurrah! No escape from the screen. It is stuck in this infinite running off to the right loop. But now you have a good understanding with this demonstration here that we've created a class of squares. The squares are good at drawing themselves, and this square is going to move at a constant rate of 160 pixels per second multiplied by the amount of time that has passed in between each frame update. This is good. This means that even if your computer runs with a slower frame rate than mine runs at, like 24 frames per second or 30 frames per second, it will still move at this same rate. And even if your screen updates at a much faster rate, like 500 frames per second, it will not speed this up or slow it down in any way whatsoever. It will still be moving across your screen at this constant rate. This is the basics of creating a animation frame loop. Now I've covered the classes and I've covered the animation cycling for this project. I'm going to get on to our first event listeners, which is going to be for keyboard events. I'm going to create a function, make keyboard. Doesn't need any arguments given to it in the brackets for now. And inside here we're going to create an object called keyboard, and inside the keyboard is going to have a function. Let's see, keyboard, well, my mind's messing me up here trying to remember how I was going to write this stuff. I want to do keyboard.handler equals function, and we're going to define this whole handler function in here with this keyword event. Over here we're going to do window, which is like, you know, built into JavaScript, add event listener. And inside here, we're going to do key down. I believe it's key down. I think it's either that or key press, but basically one of them is obsolete and will do the same thing as the other one did. So key down, key pressed, doesn't matter. Now we need the keyboard.hand. We're going to we are going to call the function that this keyboard handler does over here with keyboard.handler.bind, and there's an annoying reason for this with the .bind, but I'm going to make a reference to the keyboard in here. If it didn't work, if JavaScript didn't work this way, I would have just written inside the keyboard handler this dot whatever to call reference itself, and I would have made this all in a class. But because the word this does not reference to the keyboard inside of here, no matter how I tried to type it, this is just how I'm going to have to perform it. And then I'm going to add another window event listener key up into the keyboard handler.bind keyboard. And then inside this keyboard handler, I'm going to console.log the event. Now, oh yeah, I have to actually make a keyboard as well. So let keyboard, and inside the onLoad function, oh, I have to put it into here as well, return keyboard. So when we call this function around here, make keyboard, or keyboard is equal to make a keyboard. Then when this make keyboard function happens, at the end of it, we're going to return this keyboard here. Now that we've created it, we can see in the console here that we have these events happening here. Whenever I press a button, you can see all these events are happening here. If we click to open this keyboard event, we can see a list of pretty standard, lots of different properties behind this event. Character code, the code, composed, control key, blah blah blah. What we want to look for is things like the key code and the type, which is key down here. So instead of console.log event, I'm going to do console.log event.keycode. Is it with a capital C? Yes, it is. And then event.key, I don't need that, event.key, just event.type. Now, when we're pressing different numbers, we can see what the code of this button is. So let's say I want to know what the key code of A is. Then I press A, I'm pressing it down, and it's telling me that the key code behind A is 65. If I want to do S, it's 83. If I want to do D, it's 68, and 87 is for W. So I'm going to write that here. WASD. Let's get rid of that. So W is 87. The number 8 on my keyboard's getting funny and old. A is 65. S is 83. And D is 68. These are in comments, by the way. This just signifies that they are comments, and when this code is functioning, it will ignore and skip these lines because of what they do. Now that we have gathered the information I need to figure out whether or not this keyboard is needing to listen to these, and whether or not the keyboard is listening to these key codes when they happen. So down here in keyboard.listen, it's going to equal a function key codes, I'll demonstrate first as just key code, so one key at a time will be passed in. Keyboard dot keys. I'm going to call them that. So inside this keyboard here, I'm going to define this one property, keys, and it's going to be a array. No, it's going to be an object. Then over here, inside the keys, the key code is going to be the key that it's going to look for in this object. Similar to how this looks right now. So if I wanted to reference keys, keyboard.keys, I would get that thing. If I wanted it to be the W, I would want it to be keyboard.keys.87. But since I don't know what numbers I'm likely to pass to it right yet, or in the future, I'm going to just set it to keyboard.keys with this key code for now in these array-like brackets is going to equal to an object itself, pressed equals false. Now I'm going to just copy paste this, or cut paste this stuff over to here, and then I'm going to tell it keyboard.listen 87, which is the W, ASD, which would be 65, S 80. If I can hit the 8, and then D 68, ASD. Now keyboard.keys with this key code, blah blah blah. It's going to be listening. It's going to have these four keys to listen to. Now in here, let keycode equals event.keycode if keyboard.keys, and in these array-like brackets again, if keyboard.keys keycode, so if this is a key code that this keyboard object is listening to, then we want to perform some functions into here. If event.type is equal to key down, then keyboard.keys /key code dot pressed is equal to true. You remember we wrote it down over here, pressed equals false. Well, when the keyboard is being pressed on that key, then it's going to be equal to true. Else, if event.type is equal to key up, then keyboard.keys keycode.pressed equals false. So, and with that, I think that is all we needed to do. We just needed to know the key code. I'm just going to paste that here with a capital C to make sure I don't make any mistakes on that front. So if the key code is a code that our keyboard is listening to, it will figure out if the type is a key down, being pressed down, or if the type is being pressed up, setting it to true or false accordingly inside here. That's fine and dandy, and I think that is all I wanted to show here. I'm going to do just keyboard. Yeah, I'll leave that here for now. Now in the update function, let's make sure there's no errors coming up. That's fine. Now, instead of this stuff happening, we're going to set up some new commands for it. Well actually I'm going to just create 4 lets. So let up equals keyboard dot, what what was the thing called again? Keyboard.listen. Right, if keyboard.keys 87.pressed. Oh, it's not if, just it's up is equal to whether or not 87 is being pressed. Let down is equal to keyboard.keys 83.pressed. Left is equal to keyboard.keys 65.pressed. And let right is equal to keyboard.keys 68.pressed. If left, so if left is being pressed, this statement will be true. So if left is true, then we're going to say let x speed equals 0, let y speed equals 0. Right, we're just creating two a x speed and a y speed variables here. If left and not right, actually I'm going to just write it differently. If left or right is being pressed, then in here we're going to do if left and not right, then x speed is going to be equal to 160 times delta. Else if not left and right, but if left is not being pressed but right is being pressed, then x speed equals to 160 times delta. And in this case, actually, left would be a minus because we're going towards 0. We're going down, versus when it's going to the right, we're going up. Else, x speed equals 0. And the same thing down here, x speed equals 0. Now, if I'm hang on a sec. Left. Console.log left right. Oh right, I'm not applying the x speed to the main square. Add equals x speed. That's what I forgot to do. So, let's backtrack. If left or right is being pressed, we go into this block. If left is being pressed, only left, then the x speed will decrease, will be a minus number. Else, if right is being pressed, x speed will be a positive number. Otherwise, if we're pressing both the left and the right at the same time, the speed will be 0. And if we're pressing neither button, then there will be a speed of 0. And then we apply that speed onto the main square's x position here. So now I can move the square to the left and I can move the square to the right. We have that much control going on. Now to do the same thing but to up and down. So inside the if up or down is being pressed, if up is being pressed but down is not being pressed, then we need y speed equal to minus 160, again because y speed would be going up and that is a negative number. We need to move, it's moving towards 0. So that's why we do minus the 160. Else, if up is not being pressed, so up is not being pressed but down is being pressed, then y speed is equal to 160 times delta. Else, if neither button is being pressed, y speed is being set to delta, and if both, right, up here is if both buttons are being pressed, up and down, y speed equals 0. Else, if neither button is being pressed, y is still equal to 0. I don't think I need actually that last else there. It doesn't actually ever trigger, I think. It's unnecessary. I shouldn't be throwing in unnecessary lines here. Now again, we apply the Y speed to the Y position, and now if I want to move up and down, I've got that accomplished in here. Goody doody. I'm going to now make this speed variable, which is going to equal to 160, and I'm going to copy paste it in place of these over here, because I would rather have minus speed or speed times delta blah 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 and so on. That way if I change the speed over here to 200, it references all of those references of speed. Now I've got good speed at about 3. Let's do 350. 350. Yeah, some people saw that one coming. Now, because this object is going to go off the screen, violation, request animation took 610 ms there. That's not always that very common. I don't know why it happened now, but it has. There we go. I'm going to add inside here one more command in the update, well, not command, I suppose a few set of instructions to make collision happen. These really simple collisions. We'll be making some more advanced collisions in my next video, I plan, but for now I'm going to do some simple if statements. If main square.x goes underneath 0, which means that the left side of this square is going off the screen to here, then main square.x equals 0. So we're stopping it from going off the screen to the left. And the same thing is going to work on the y-axis. If the y goes below 0, we're going to stop it. That works fine enough. But now how to handle these ones is going to be a little different. Else, if main square.x plus the main square.width goes over the game width, we have to include the width of the square to the x position of the square so that we're getting this right edge over here. And then if it goes too far, that it goes off the left side over here, we're going to have to stop it. And in order to stop it, we do main square.x is going to equal to game width minus the main square's width as well. That's where we stop the square going off the right side of the screen. And we do the same thing with the other dimension, the y dimension. So if the main square's y position plus its height go over the height of the screen, then the main square.y is going to equal to game height minus main square dot height. Now, I guess people might tell me that I should be including these brackets on the ends here, but as long as you are only putting one line or one statement after an if statement, you're allowed to get away with this. But for some sake of for teaching some people, this is probably what I'm doing is probably very bad practice. I'm just hoping to explain it now that I'm doing a bit of a bad habit here, where if I'm only making one statement like I'm doing over here, just one command is happening after this if statement, then I'm allowed to do this. But if you want to make more than one thing happen after an if state happens, then you have to make sure that you put all those statements between these brackets. Now, if that's out of the way, now we have set the boundaries that this square cannot leave this room. It is stuck inside here, but you have control over it. We have now accomplished creating the classes, which is the rectangle in this case. We've accomplished animation frames, so it updates at a constant frame rate. And we've also accomplished giving you some keyboard controls over this square, so that you can move it around the screen as you want, which is pretty much my mission achieved for this video. if you wanted to go further down this road, a fun idea would be to start adding in a load of other variables to this square. You could easily add friction, which might look something like 0.9, and then whenever the left and right key isn't being pressed, then you could just say x speed times equal friction. If you wanted to add acceleration could equal to, how fast would it accelerate? Maybe 50. So what you would do in here, instead of minus speed times delta, you would do minus acceleration times delta, and it would get faster and faster. Alright, you would do minus equal acceleration times delta. But you also might later on need something like if x speed goes underneath max speed, and you might define max speed as a constant, so max speed might be that 350. So let's just imagine as this: if x speed goes under minus 350 and x speed equals 350, you do not want it to go too fast. Of course, it could go, if I didn't put this limiter on to it, it could accelerate off the charts, and it will fly. If it flies too fast, you'll see a lot of this in Sonic games, where the Sonic character is moving so fast that he will just, you know, there's a ball here, boop, boop, and then past a solid wall. And sometimes in games that happens when the wall is so thin and the character's hitbox is just so moving so fast that there's no frame in between where his hitbox is overlapping with the wall. So often, more than not, you will create these maximum speed limits for your characters. That's how you could go about adding acceleration. And with friction, you might also say if left and right and x speed is, you might do math to absolute, so even if it's a negative number, it will translate it, I think they're called, to a positive number. So math to abs x speed is less than 5, then x speed equals 0. Otherwise, it will constantly be trying to create a smaller and smaller fraction of this number to go 0.0001, 0.000005. You don't want it to keep doing that. Once it gets to below a certain speed, you would just do this to cut off the friction from happening. Other games might also do gravity, so gravity might be as simple as equals 2, and then on every frame you might want to do the y speed add equals gravity, and again if y speed goes over a terminal velocity, and you might name that terminal velocity somewhere like here to be, I don't know, 100. If it goes over terminal velocity, then y speed equals terminal velocity, just to stop it from going too fast downwards, because again, if you go too fast downwards, it might miss the floor and just go straight through it without ever seeing any collision happen where it should be happening. It would just go fell through the floor. It does happen in games. This is how you might just apply some of these simple ideas, let's say. But I'm not going to make this drag on through writing all this stuff up. Now, if I'm right, I'm going to put this all back to how it was. This is going to equal 0. X speed equals 0. Yep. Alright, minus. There we go. We got back to what we had before. There is one other problem that some people might notice, is when the character is moving diagonally, you might notice that his speed is almost doubled technically, because he's moving at a speed of 350 pixels per second horizontally and vertically. And if you know your math.square root kind of maths, you'll notice then that he's going way too fast in that axis. You would rather have the movement look more like a circular kind of movement. So even if he's from the center trying to move that way, there would be, he wouldn't travel like this far, he would be traveling about this far. And that just requires, again, a bit of maths. I'm not going to touch that right now because I have not researched and looked up how to do it properly. But it's just there for you, food for thought for people who do know a bit of that stuff, how you would quickly implement that to make sure that even though this character is moving too fast in these directions, you could limit that. I'll probably get to that in a future video somewhere along the way when I'm starting to run out of other content to throw in. But that's basically the basics covered for classes, animation, and controlling your character's movement on the most simplest level of stuff. And I think I can call that the end of this video for today. I hope you enjoyed watching, and we'll come look towards the next video where I should be starting to add more events involved in things like collision detection going on, like when one square overlaps a different square. We're going to look into events happening there. I wasn't sure what other stuff I was going to start creating yet, but from there I was planning to make some kind of an enemy character that might hurt your health bar and potentially kill you if you lose your health bar. I might also create I might also do a bit about keys, like picking up an object and then taking it to a door to open the door and reach a goal and reach a game over screen, or you won screen at least. And somewhere in the mix, I know I've got plans to do a video covering how to start drawing some sprites and graphics, possibly in Photoshop with sprite pixels, and then I'm going to figure out how to import those sprites into this video so we can replace all these pretty boring looking squares with these pixel drawings that we'll do. But I hope that you've enjoyed part 2 for now, and will be interested in joining me for part 3, possibly on Saturday. And meanwhile, have